Assalamu alaikum. Due to the current COVID-19 pandemic, all the JEE aspirants are stuck in their homes. I have started this online lecture series to help all those students. I hope that they will find it very useful. Stay home, stay safe. Assalamu alaikum warahmatullah. So today's topic is the combination of the resistances. We have already completed the first part of this topic. So let's say we have a kind of a question like this. For example, this combination, and this is the point A, this is the point B, and we have to find the total resistance between A and B. So these dots, it means that you can say the length of this circuit is infinite, or we can say there are infinite number of resistances in this circuit. Practically, the infinite does not exist anywhere. It's only a kind of a mathematical concept, but still at times when we can say lost the track of those counts, or it is always a comparative, you can say, relation. When we compare a number with some other, we consider it infinite maybe. So if we have an infinite number of such resistances and we want to find the net resistance between these two, A and B, so how we can solve it? Now let's start with this. We can have a 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm, and likewise, but let's say it is R ohm, R, and R, and R, and likewise. How to do this? Now, it's very kind of a basic question of this, and this is known as ladder type. This kind of it forms a ladder. So how to solve these questions? Very simple. See, we have to see the pattern and which part of the circuit is constant and which part of the circuit is repeating. So if we see very closely this part, this is the, you can say, A and B, this is very much constant for all the circuit. Now this R and this R, they are neither in series nor in parallel, but these two R's, they constitute a pattern that is repeating. So this part is repeating. This is the repeating part. This is the constant part, and these are the repetitions then, and this will go up to infinite. So this repeating part and this much. So conceptually, if we say we have infinite number of these repetitions, if we subtract 1 from the infinite, it will again remain you can say infinite, but that is the fallacy, and it's very strange, but still we use it in our day-to-day lives. So in this circuit with the infinite repetitions of this pattern, what we will do, let's suppose the net resistance between A and B is X, for example. So let's call it X. We have to find this X. Let's suppose this is X. Find this is X. Now this is the first, you can see this part that will again repeat itself. So this part and R, we consider it like this. But let's suppose what is the value of the net resistance between this point and this point. So up to this point, there were infinite repetitions. From this point onwards, there will be infinite minus 1 repetitions. But infinite minus 1 is again infinite. So the value of resistance between these 2 points, after, you can say, considering this first part, after this, the resistance between these 2 points, this will be almost exactly equal to the real value of the resistance. It's the X. So we can redraw this like this. We have A, we have B, the value is X, then we have R, then one more R, and then onwards, since this this circuit will again repeat itself infinite times, we can say this is again x. So we have to find the value of x, and it's very simple. How? From this circuit, what we get, that this is the net resistance, that's x. This is equal to, this x will be equal to R in series with, it means plus, R and x parallel, R parallel x. And how we can write it? It's like this, R plus Rx divided by x plus R. Now, what is this? This is a quadratic equation, simple. We will simply cross multiply. It will be like x square plus xr equal to rx plus r square plus rx. XR cancel. So we get x square minus xr and minus r square equal to 0. And you will solve this and find the value of x. So it will be possibly, it will be like r plus minus under root of something like this. So this is, you can say, a type of question that we can, you can say, do on this topic. The next question that you can say may be asked, or that's again a good one. The kind of repetitions, we have to make sure that we understand those repetitions. For example, we have a circuit like this. So this is A, this is B, this is something value, let's take it a 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm, and infinite. Again, we will do the same thing. First, the constant part, that is between these two, this part. Then the part we have to see which part of the circuit is repeating. So we see this, this, this. Actually, these two are repeating, or maybe these two are repeating. So this we have to see. For example, if we say only this is repeating, that's wrong, because we have this one at the top. If these two are repeating, or maybe someone would say 1, 2, or 3, these three resistances are repeating itself. For example, we have this bunch, then again we should have the same bunch. But see, in this, you can say group, we have three resistances. If we say this in the circuit, this is being, you can say, repeated, or this has been repeated. But again, here we have only two resistances. This we have already included in the last one. So this is not the proper repetition. What can be the, you can say, the other case can be these two. We are repeating these two, yes. These two, then again these two, again these two, and so on. So this is the repeating part, and this is the other part. Again, let's say this is x. Redraw it. So we have x, then we have a parallel one, then we have a 1 here, and what remains there is again x. So how to solve it? Again, very simple. This is the net value. So x will be equal to, net value is equal to how much? These two in series parallel with this. So 1 plus x is in series. It is parallel with 1. Sorry. How to solve it? So x equal to 1 plus x multiplied by 1 divided by 1 plus x plus 1. That's x plus 2. And cross multiply, x square plus 2x minus x minus 1 equal to 0. So x square plus x minus 1 equal to 0. Solve it and we will get the answer. beyond this, we can say on this ladder problem, we can have some good questions that have been asked mainly in the advanced level. For example, we have a question like this. We have a question like this. It is 2 2, then it is 4 4, then it is 8 8. Obviously, anyone preparing for the JEE, they know we have to know the basic sequence and series. So this is kind of a 2, we are doubling it, it's 4, then it's 8, and so on up to infinite. How to do it? It's very simple. Again, the constant part is this one, the repeating part is this one, but the repeating part is not constant. What is happening in the repeating part? If this part is maybe whatever we say, if this is R, this part, so this value is 2R. So this is double the value of this. So how to write it? So actually it is 2 2, then it is double 4 4, double 8 8, and likewise. So we can redraw it again. We would say this is, maybe we can generalize it. This is R, A, B, this is R, this is R. If this is X, what will be the value of this? It will be, obviously, it will be 2X. We get it from this question. It's very simple, not that difficult. From this point onwards, the value of the resistances, this is double the value of these resistances. So it's double this value. So if this value is X, the remaining value after the first, you can say the repeating part, it will be 2X. So again, we can solve this equation and find the answer.